Okay, so on the workbench, I guess what better place to start than with the case itself. This is the 2-DIN indash 7-inch Samsung with HDMI. The link will be down in the description. This is the HDMI model. I also gone ahead and got the add-on USB board. The reason why I haven't moved it yet is because I will say that this board is a little finicky with it bolts top and bottom, and which gives you USB buttons you can program on the front, and it tweaks so the buttons in the middle don't quite push. You'll see I put a little bit of hot glue there to kind of hold the board flush against the metal. I don't want to get this metal here too hot though. I was going to put like a 3D printed bracket that pushed in on it, but I didn't really apply any pressure to the screen because they start warping the screen. So a little bit of hot glue actually this holds the board flush, so it's good. And you'll see all the USBs hanging out. So let me turn this around. Pretty basic. You've got see, there's the programmable buttons, which are on the case by default, but they don't work unless you get the extra card. I think the power button on the top works, and that's it. The on-off button, brightness, and USB. The only thing I didn't actually use in this project is the auxiliary audio input, and that's because of the sound card issue that I previously discussed. I ended up using the port on the motherboard I was going to use for that one for the FM input instead of the sound card. I think I may go back and readdress that at some point, but for right now it's going to be fine. Yeah, so it's pretty good size. Like I said, I've cut it down, so from the depth to here it's 7.5. It's actually just shy of 7.5 inches. You can kind of, based on my hand here, see that it's not very big in scale. Let me get that out of the way. I have everything arranged so well. Okay. What did I do with that? So here's the piece that I removed. I just measured it all out and cut it up nice and straight, which originally was, actually it was like this. It was originally attached like this. So I've removed quite a bit. So now the depth is much smaller. Okay, so that out of the way. Next big component is, dun, 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 dun. I know this is what you've all been waiting for. If I was a good host, I'd probably save this to last, but this is what makes the whole thing possible. Let me address my notes over here. This is a Nano Itx made by Jetway, and it is a JNP93-2930. The 2930 is what CPU it uses. It's a fanless Intel Bay Trail M Celeron, 1.83 gigahertz quad core, 7.5 watts, 2 gigabytes of DDR3 Ram, and the whole board, the whole freaking thing, measures in at 100 millimeter by 72 millimeters. That's kind of the board out of the way. You can kind of see that the whole bottom is a heatsink, which is kind of amazing. And even at full 100% CPU load, this thing gets just warm to the touch. That's about it. Also, you'll see here on top, I have a Kingston, it's a Kingston SSD hard drive, M-SATA hard drive. Let's see, where did that go? Yeah. So it's an M-SATA hard drive, 120 gigabyte, 6 gigabits per second, and I ended up finding that used for a really good price. I am very happy about that. This thing has tons of peripherals. HDMI, USB 3.0 and 2.0. There's 2 on the back, but there's also room for up to 4 on the board. You can see here flopping around, I've actually got one of them. Pretty much every connector you're going to see throughout this whole build, I have the plastic cut off. That is for size and allows for bendability so I can get more room. Anything I thought was going to short out, I Kapton taped it. That's Kapton, Capton. I don't know, some people pronounce it different. You'll see some more of that over here, which I've used for the tape. Just look up Kapton tape. Cheap stuff. It's thermal resistant and electrically non-conductive. So that is the motherboard. 64-bit compatible, runs pretty much every Windows operating system that there is. I decided to go with Windows 10. I was going to use 7. Windows 10 I think boots a little faster and had some nice tablet features built in, which is kind of nice for a touchscreen application. So yeah. Over here is a USB, or excuse me, USB. It's not USB, is it? That's the audio input-output jack. I made my own connectors. There's something to be said about that. Let me definitely address that right now. Let me push this piece on here so I don't have to worry about it later. I'm going to go through a whole assembly video with you, but that's where those go. You'll see there's no actual audio ports on the back. There are pins on the board. So the only issue I have with this board is that every pin on the board is 2mm pitch. Yeah, 2, not 2.54 like every other motherboard ever made. 2mm, and I had a little bit of difficulty finding pins. So I was able to find them. You can find them on eBay. I found one supplier for both the pins and the connectors. These were actually cheap. Took me nearly a month to get them from, I think they were China or Hong Kong. Then to actually crimp your own wires, you'll need a tool just like this, which this was actually easier to find. This one here said it did 2mm, but I'm pretty sure that all of them are made for 2.54. So don't bother looking for one that says 2mm, because they pretty much are all 2.54, but with a little bit of practice, you can get 2mm with it. Yeah, it did finally do a pretty good job out there. I kind of tweaked it and figured out how to hold it, and etc., etc. So, that out of the way. Next major component is the USB hub. You'll see the picture up in the one of the corners of what it looked like when I bought it. Obviously, like everything else, I took the case off for size constraints. These are handy little boogers right here. I got these from Fry Electronics. They are just universal barrel jacks. I probably could have hacked this one apart like I did for the motherboard, which I'll show you in a little bit. But I cannot get that back in there. There it is. The wires actually attach to the well, what did I do with that? No, it doesn't matter. I'll come back to it. Oh, here we go. Nope, that's not it either. Shoot. Well, I had all of this laid out. Oh, here it is. Yeah, that actually plugs into this little wire right here that just snaps in, and it's good for testing stuff. So, okay, USB hub. This was a powered hub, because I definitely had a lot of USBs that needed to go in, and this one here, it actually I probably could have used all the ones on board, but it was easier to use this because I wanted external power. This thing here ran out of USB power quickly, so I didn't want to run too many large devices directly off the board. So this actually allowed me to address that by having its own power, which I kind of ended up cheating and using the power from the board to power the hub, but it didn't have to supply it through the USB port directly. What I ended up doing was, because this one here also supports, as you can tell over here on the side, a SATA drive and a CD drive. So it was able to put out some major amperage on this port here, which I'll show you the wiring for here in just a moment. So basically I used the hard drive output to power the hub. So they didn't have to pull it all from a single USB port and put it out through a better regulator, and that works very well, surprisingly. Now, this is one of the brackets that I use for the actual motherboard, which is 3D printed. It's not gorgeous or pretty, but it functions very well. It goes over the it goes over this way. Actually, it goes this way. It goes over the board. The board mounts inside of it, so it can't move. And then the width of this piece is exactly the width of this piece, so it can go in and not slide around. And I will show you how I install that here after I show you all the components. The next big component is, I think I mentioned this is a 7-port, yeah, USB hub, 7-port, 2.0 powered hub, eBay special. Next big piece is this baby right here. This is pretty much what makes it all possible. I scoured the internet forever until I found just the right power supply, because you'll see other Carpc power supplies, but they're all meant for mini ITX applications. Plus, to make matters worse, most of the forums I've creeped through, lots all said that those power supplies for the ITXs are noisy as crap unless you get the most expensive one. So I needed a power supply. Oh, by the way, this is 12 volt. But you're not going to be running this off your Carpc. It needs a regulated 12 volt. No big surprise there. It's a motherboard, right? So I needed a device that. So let me say what this is. This beautiful piece of architecture, yeah, is called the DC to DC USB 200. It's made by I'm gonna totally murder their name. Cyncronix or Syncronix. It's called an intelligent buck boost converter. This has got 5 12-volt rails, and it does a total of, oh, I did not write that down, 15 or 20 amps altogether, but that's a cumulative, or excuse me, that's for all of it, for the whole board. It doesn't really have any specs what it'll say run. It doesn't say what it'll run per voltage rail, but I imagine that's probably divided up by 5. I'm not pushing this thing at all. I think the whole system doesn't go over 2 amps, and that's across 2 different voltage rails. So very minimal there. But it is an intelligent power supply. You'll see that it has USB capability. You can actually plug it in all the time and change it on the fly. I pretty much didn't have to. It has the ability to run scripts for shut on and shut off. You can actually control other peripheral through external relays by running scripts based on certain criteria. I didn't use any of those, but I may actually in the future for the cooling fan. You set your voltage you want it to maintain no matter what the voltage in is, and you can also set whether it acts as a automotive power supply or a PC power supply in an automotive state, so that this will actually send the power on off signals to the motherboard, and all that wonderful stuff. The one major modification I made to this, which will definitely void your warranty, is you'll see these wires hanging off. This thing originally came with a plug, so you plug it in from either side, and with the width constraints in here, being able to plug it in from the side was not going to happen. I needed to be able to plug in from the top. I was unable to find any of those Molex connectors that came straight up like this, so good old fries, I went to buy some of these cables, which are pretty much meant for high-end graphics cards. Graphics cards? Is that what they're for? Yeah. Well, yeah. Anyways, you can find them in the PC section. And then I just, I cut those really short and soldered them in and left these extensions along. This is the one that actually comes out the back for powering the whole unit. Also, you'll see on the bottom, this is one of my 3D printed brackets, so that it doesn't touch the bottom metal and short out, and like everything else, it slides right in with the exact width so it can't move around. Yeah, so that is that piece. Oh, and also you can adjust the timing. So this senses the ignition. It senses the power of the battery. So even in its hibernation state, which by the way, when it's in its hibernation state is like a micro amp. It nearly pulls nothing. But you can adjust the timing between when you turn the ignition on to it supplying power, to how long it takes before it gives the power on command, and inversely it'll control seeing the ignition being turned off, how long it takes before it sends the turn off command, and how long it waits before it kills the power. So you can time how long it takes for your application to completely shut down before it kills all the power to the system. That way everything has a safe shutdown every time. It also has a battery monitor, so even in its lowest state, for some reason the battery voltage got too low, it'll make sure that it still has enough juice to start your car. And it also handles heavy cranking. This thing can supply your 12 volts regulated, even down to 6 volts. So even if your car goes down to 6 volts while cranking, it will still maintain the 12 volts going through your system, so that you don't have a brownout scenario and have issues and fry stuff on the board. So that's pretty much all you need to know about that. Is the sound card that I previously discussed. You'll see over here what it looks like when it was in its stock state. I cut it down to get the width down a little bit, and so the output, this is a really cheap USB sound card. This is an external virtual 7.1 USB 2.0 sound card. This thing is like $5, and the sound output is quite good. The mic input though is mono, so yeah. So there's that, and it pretty much does as described. It has volume buttons and stuff on the casing, but all I really do is send commands to the PC and change those, so they don't really matter. I don't really use them. But the sound output is quite amazing for a cheap little Chinese part. It does a good job. I'm really quite impressed with the sound output. But yeah. So that being said, it just works. I ended up using I was not planning on attaching these to the board, but because the input on this thing here was a piece of crap, the one that actually goes in factory into the board has a stereo mic input or line input, so I used that one for some reason. This one here has an output too, but everybody knows you don't use the sound output from the motherboard because you always get a whole lot of noise whenever it's making processes. So basically I'm just using this as a sound output, and I'm using the one on board as a sound input, and that's pretty much exactly why I have two. So there's that. The next thing is the Wi-Fi dongle. These apparently are hit and miss. You can go on eBay, there's 1,000 ones just like this. I ended up I had bought 2 or 3 of them. They all look pretty much the same. I don't have the other one in front of me, unfortunately. They seem to be hit and miss on which ones this board or Windows 10 likes. This one, if you go to eBay and you look for Wi-Fi dongles, this is the one that says 300 megabits per second. This one seemed to work good. The other ones that did not say that, which the only real difference you can see is that the casing is slightly shorter and it's not curved like this. Those did not work well. They work in everything else, but they didn't work in this thing for some reason. You can go for the small dongles that don't have the external antenna, but this is going to be in a big metal dash, and I have been getting good results with the antenna kind of wedged inside, and it's been working okay. But I wanted the option to grab something like this and hide it up in the dash closer to the plastic, so I had a good signal, because I really want to be able to cycle my car via remote wake up and be able to send music and movies to it from inside on my network without having to go out to the car. That way when I go for a ride, I already have the music I want to listen to, and other various reasons as well. So that's the reason why I went with an external antenna instead of the internal antenna. The reception seems to be much better. Then, you can't have a Carpc without FM. This is the HD Radio receiver by Directed. You see, also like everything else, the casing is off for space. The model of this is a DMHD 1000. I think it's 1000i or 1000L. You know how the font sometimes don't make that clear. But I will put it in the description spelled exactly as it's spelled. You'll also see a picture of what the box looks like up here, so you can find it easy. These, I guess, are no longer made anymore, but everybody and their brother are still selling them, so there must be a lot of stock floating around. If you're planning on doing a project like this, I would definitely buy this component first, because the rest of this is still widely abundant. This piece here, like I said, they're no longer making, but the sound is amazing. It has RDS, so it shows you the name of the stations, what's currently playing. You see I made some modifications to this one here. I took the RCA jacks off for space and just straight up put a headphone jack attached to it. I did have to remove this big metal piece, which is kind of a nightmare to do, and then I hand soldered the antenna connection so that I can hang it out at the back, and I hot glued it on here so if it got yanked on by accident it wouldn't pull those solder joints out. And that's pretty much all there is. You can see here I capped on taped over the external electronics that were the highest on the board, so that when it was in, because it goes in there upside down, which I'm going to show you with that bracket over there, it actually goes in and mounts upside down to the top, and I didn't want the electronics touching the hub. And now what makes this baby work with your computer, because it technically has a USB, or has a interface device that you're supposed to like Velcro to your dash or whatever, but what makes this usable in a PC application is the next crucial piece, is this interface cable right here. You see I've taken the case off of here, which will be a picture of what it looks like in its factory state. This wire is quite a bit longer from factory, and I didn't need nearly that much. I cut the casing off of the connector. I actually looked up this connector. It's called an 8-pin. Darn it, I wish I had wrote that down. I will add it to the description so you can find these pins. You can actually buy this pin. But it comes with the kit. Pretty much everything you see right here comes with the kit, and it comes with a driver CD. But basically, I cut the casing off of it so I could get a harder 90-degree bend. The wires are still attached, and it's hot glued inside, and the black tape just to make sure the stuff doesn't short out. But I made it shorter by just cutting the leads off. I documented what colors went where, and then resoldered them back to the board. Extremely useful cord. Oh, I should probably tell you what it's called. It's called an MJS, or that's who it's made by, but it's called a MJS HD Radio USB PC interface cable. It's a mouthful, but that's exactly how you look for it. It's a little bit salty, I think, for what it is. It's not much more than a cable and an FTDI chip, but you can't do it without it, so it works, and it works good. The cables that power that FM unit plug looks like this. I obviously shortened those up quite a bit because there's like 15 feet of power cable. I left a fuse in place. This thing here is huge. I took it apart, and basically it's a oh gosh, what's it called? It filters out the high frequencies in the power line, so you get a good clean signal when it's powering the FM. I wanted to remove it, but in a car application it makes sense to have it so they don't have it high frequencies in your power line and mess up your sensitivity of your radio receiver. So in the end I had to leave it on there. Filter and fuse box, so I guess there is a fuse in there too, but it's basically just got a high frequency filter built into it, which in a noisy environment, as I'm packing it in there, I figured it was probably a good idea to leave it in there. So yeah, this is the power plug that plugs into the intelligent power supply. You'll see that 1 volt rail, because they're separated this way, 1 voltage rail powers that. The other voltage rail actually powers the motherboard. This one here, you'll see I've actually taken apart the barrel jack because I needed a 90-degree barrel jack for space, and so those are surprisingly harder to find than you might think that would fit within the size constraints. So basically I just cut apart one of those test barrel jacks and then got it to a perfect 90-degree, and then hot glued the crap out of it and used cardboard to shape it. So that's that. The over here is the bracket that I made that the FM tuner mounts to, which in turn mounts it to the top. I will show a better picture of what this piece looks like, and also all my 3D printed pieces I will attach them so you can download them and use them. but this is the top piece. So the actual FM tuner is mounted to the top, and then the top goes on just like this. And last but not least, the back plate. I 3D printed this back plate. It mounts right in the back. Has spots for my audio connectors to come out. The power connector clips right in there perfectly. That's what this is. It clips right in, so you don't have to access the inside when you do the power. This hole here is the exact size of the antenna, so this piece here, so it slides right through, is allowed to hang out. This extra hole here was for something I ended up not doing. I think I'm going to revisit this and do a nice port where a fan can mount in really good. I have not figured out how to control the fan yet, because this motherboard does not have a fan controller built in. I was kind of disappointed about that. So I may be visiting a Arduino, a Pro Mini in the future to actually get the temperature and control a fan if it requires it. That's pretty much it. This is the handy cable here. It's pretty simple. This one plugs into the screen on that for the power button. This one here plugs into the intelligent power supply, and then this one, and then they all, they're in parallel with each other, as you can see there. And this one plugs into the motherboard to do on and off. That way you can do it manually, or you go over here, I guess you can do it manually from the front, or you can have the intelligent power supply turn your motherboard on and off. Yeah, that's pretty much all there is to that. And that pretty much covers everything. So in the next section, I'm going to assemble it all, and you can see how it all goes